So known as a therapeutic robot, this project used our developed platforms and also on the shelf robot. We've also bought some robots from the companies as well to serve research and development purpose. And most of our work back at our lab, actually we're focusing to develop computational framework, especially models, implementing existing AI techniques, because we can see that many AI techniques are technically matured already. So you can write codes on Python, for example, rather than to write from scratch, you can use libraries to do this. So you can set aside in futures where social robot will become a platform to demonstrate an array of AI techniques in the real settings. And also that we also work with other technologies like speech recognition, agent-based modeling, emotion analysis using deep learning, and also natural language processing. So, and in our group also we have people from other degree program, not really computer science, but also from arts program, because we need them to work together to make our framework or robot work well. But throughout time, what we have learned from our practical experiences, at least within our lab, my team and I have learned several important takeaways. For example, social robot will need to excel at reading our intention, behavior, desires, and to adapt to respond to our like human behaviors in a sense, because our behaviors are intuitive, technically very messy and unpredictable. So social robot needs to figure it out what the human partners, us, wants and intends and assume, and then consider these interference or inferences to adapt its own behavior and respond correctly. So this is the main challenge that we have faced eventually. It's not really about the programming part anymore. It's about to understand the cross-cultural perspective, how we understood things, and also that how we perceive other parts. Programming part, inshallah, from computer science point of view, we can tackle that. But how to capture those, what we call the implicit knowledge about human, that would be one of the greatest challenge. And also that social interaction should be based on localized lingos as well. I mean, we have like English-based, but how about people use different dialects or accents? So this kind of a technical challenge should be tackled. The interface also must be well understood, like when the robot smiles, people will understand that it's smiling. And we do not need special technical training for particular usage, and the robot must be capable to interact with many individuals at the same time through speech and vision system. These are the things that we have learned from our experience. This basic behavior seems to look simple to us, but for these robots, it requires more than meet the eyes to ensure its acceptance in the real world. So what we can get from this particular, what we call it, the experience, how to get it that far, people must want to socialize with the robot first. And when a person is interacting with a social robot, like Furhat, it should feel much more like interacting with a someone rather than a something. This is the main tenet that when we try to design a robot like this. In other words, a successful robot is one that we perceive as having some agency over its choices and behavior. It means that we know that robot has their own control, their own autonomy, and also their own intention why they're doing that. And we need to know that when we're interacting with something, the robot must be viewed as having highly adaptive behaviors rather than hard-coded if-then rules basis. So these are the things that we have learned through our experience building a social robot. And the good news is these capabilities and everything are encapsulated with Furhat intended design. So we have seen some demos and everything. For example, let's say Furhat can understand human behavior through facial emotion recognition. So rather than for us to get it done like manually coded everything being based on the libraries already. So you simply reuse. Because from my experience, understanding facial emotion recognition and trying to make use of it serve as one of the most important skills for any social technology to be used in the wild. Otherwise, people will think that as the idea of the uncanny valley, or people perceive that as a zombie, for example, when the interaction not really subtle, and perhaps that there might be some what we call a lack of interaction time. Also, we can see that Furhat's customizable appearances, let's say through digital projection camera, will allow more fluid personalized technology. This is a thing that we also have learned, because people do not want to have the same personality on the robot. So it will be a great challenge for us as well, because especially with kids, they wanted to have robot with different personality. So having that, what we call the robot that fixed face, really difficult to do that. So Furhat allow this particular salient changes to take place. And also that it has the visual audio conversational intelligence model. Like you can select or even program using native language that will make a good, what we call the direction for us to choose Furhat as a, in our case, for our next development and testing platform. Because this particular idea is very crucial, when we try to design a robot, people do not want to have predicted scripts when they want to interact with them. Because yes, we can build a robot or any piece of technology can communicate with us in very short time or short interaction manners, but that will be a counterproductive. You're talking about robot to be put in the real world perspective. So for that particular reason, that Furhat's capabilities and everything, with libraries and so forth, it will give a better prospect that how a truly social robot that capable to interact with us like we communicate with humans in a healthcare setting, for example, and that it could be used extended period of time. We're not talking about 10 or 5 minutes of 10 or 15 minute interaction. We're talking perhaps 15 months interaction or a lifetime interaction, as the robot probably capable of handling those interactions are. And then we need to know that the earliest generation of the robot, such a robot like this, it was designed as an autonomous task like for the industrial setting. So they are very brittle in the sense of understanding us, and it's very dangerous. Although we have a concept of cobot or collaborative robot, but it was designed not to interact with us socially. It's like to get us things done. And the robot before were designed to, let's say, explore the ocean floor, for example, let's say supplementing the manufacturing processing or helping to fulfill warehouses orders. But we can say that again, even today, over the past years, this landscape has been changing. So social robot like Furhat can be a robot-based tutor, for example, that provide learners or kids with a fun, interactive way to practice and master learning new skills like language or Mandarin language, or perhaps a Danish language as well. And also that Swedish language can be taught using this particular amazing technology. And also that it can learn to portray the student emotional reaction to different situations and gradually personalizes them by using their learning algorithms in response to optimize according to students' needs. So we can imagine also Furhat at home. It could be functional enough to serve as a family members, digital members, I can see that, and can be purposely designed with a unique personality and quirks to engage family members. So we also can see that this kind of a piece of technology to act as a digital companion to provide emotional support to the young, elderly, or disabled. We are seeing this. So we're not there yet to be the society in Japan, for example, let's say, because the demographic has changed already, because they have many elderly population over there. So where this particular work has been started, basically in Japan in the beginning. But now you can see that this kind of a thing is no longer about that. It's about how it can complement us in a sense that having a technology that can not replicate human in a sense, but also to support us to provide more subtle interaction. It could be that, let's say you have a grandkids one day, your grandkids, like everywhere in this world, might be that someone, one of your grandkids in the US, or might be that in Sweden or Japan and everything. So you can communicate using Furhat or any piece of technology as what we call the intermediaries platform and play with them in a sense. So this is a particular prime example that where robot could be used. Like we can see that some example been told us before in terms of services, hospitality, healthcare, and so forth. So we also can see that in business settings, for example, that Furhat can engage with potential customers, like to provide information about products and services, storehouse, and also pricing. I can imagine that I can we can bet that actually that we can see more amazing possible utopian future of social robot like Furhat in Malaysia to be used widely anywhere else. So I think that that's end my knowledge sharing session for today.
Thank you, Doctor. It's very impactful and informative session that you're sharing today. In fact, we have this idea, to record all our memories in Furhat, so that when
That's great.
when we die, all our data, our face, our voice will be remain for the loved one. Yeah, it could be something impactful in the future as well. So
It's like you're
thank you.
having like things on like what we call the Harry Potter things, but movie but no robot then.
Yeah. Very nice. Moving to the next speaker. Actually, in the first speaker, Charlie also mentioned about how Furhat can be used as the platform for autism therapy. I think we are looking at the among pioneer researcher that doing robotics for autism. Dr. Syamimi project was focusing on using robotics to help children with autism gaining more effective therapy and so on. So I would like to invite Dr. Syamimi, over to you.
Thank you, Dr. Hanafiah. Is my slides being seen by everyone?
Yes.
Yes, thank you.
All right. Alhamdulillah. Assalamualaikum and hello, everyone. Thank you to Furhat and also Robopreneur for organizing this event. And thank you for inviting me to share my experience in working with social robots in Malaysia. So my name is Syamimi, as mentioned by Dr. Hanafiah just now. I'm a lecturer in UTM, but currently being seconded to the Ministry of Higher Education, Malaysia. This is the content of my presentation today. I'm going to talk a little bit about myself on the robot-based intervention program for children with autism, and then how I have had some experience working with patients with depression, also using a type of social robot, and my take on how social robot Furhat can be of help in autism rehabilitation, and I shall end then. Okay, a little bit about myself. As mentioned by our moderator, I did my PhD in University Technology Mara, and I had my master's in mechatronics in the UK. And my research and teaching interests are mainly HRI, which is human-robot interaction, and also robots for mental health. Please hover to my website if you would like to know more about me. And that is an old picture of me holding the Paro robot. Okay, about robotic intervention, we know that the needs of robots has changed previously from industrial to more human-friendly robots. And robots have been used in rehabilitation, and it is moving, not only focusing on people who are in the elderly stage, but towards people who are being affected by disorders such as dementia, Alzheimer, autism, and even patients with depression. Now, intervention using robots is promising because we want to help to make the quality of life for these disabled people to be better, because they are part of our society and we want to help them to gain independence in their daily lives. Right, these are some pictures of robots, social robots mostly, who are being used all over the world to help children and also adults interact in a more socially engaging environment. And now I would like to talk about my experience in robot-based intervention program for children with autism. Now, looking from the eyes of a child with autism, basically deep down, they are still children and they want to make friends and be able to socialize. So we know that children with autism have difficulties in expressing their emotions, in being socially engaging, and also in communication. How do we help? Now, why are we using robots for children with autism? Based on literature study and also studies conducted by our team previously, we know that robots can provoke interactive and social responses that do not naturally occur in children with autism. Now, for this intention, both humanoid robots and non-humanoids have been used. However, the humanoid robot is simpler in appearance compared to real humans, thus more approachable to these children with autism. And we know that a social robot with human-robot interaction architecture has great potential to teach children with autism how to detect and understand emotions and social behaviors which are lacking in these children. Right. About robotic intervention for autism, it is actually being supported by two dimensions. When we're looking from the perspective of the children, they understand things literally, okay? And studies have shown that children with autism actually prefer robots as their interaction partner. On the other hand, robots are more simple, have reduced interaction complexities because we humans, when we talk to children with autism, we are showing too much emotion at the same time. And this can be too much information for these kids to be able to comprehend in a particular time. On the other hand, robots are also programmable and controllable. And with a particular shape of a human or a humanoid head, robots can trigger social behaviors more often than the other devices. Now, about our study, our research deals with the exploratory study on the applications of humanoid robot as adjunct therapy method for children with autism. So we want a robot to be able to help to attract, mediate, and encourage interaction during therapy sessions. And with the use of robots, we hope that we are able to improve the quality of life of children with autism, especially in areas of social skill training. And these children will need to be exposed to child-robot interaction in order for them to benefit from this method. Okay, these are some of the pictures that were taken during our intervention that we did at a center for specifically for children with autism in Kuala Lumpur. So, and the study had involved 12 children with autism. And Alhamdulillah, we found out that the results show that the children had shown good initial response towards robot-based intervention. And most importantly, the children had showed less autistic behaviors when interacting with the robot. And we also observed that children with IQs more than 80 prefer robots during the interaction compared to interacting with their teachers. And we also conclude that child-robot interaction need to be highly similar to actual human-to-human interaction and more socially engaging to the children in order for the robot to be able to teach social skills. Now, moving on, other than using a humanoid robot, I have also had the experience to use a social robot in the form of a very cute robotic seal to help patients with depression. Now, we know that depression happens all over the world, and statistics show that in year 2020, at least 10% of Malaysians had been affected by a form of depression at a point of their lives. So depression is actually a very serious mental illness, and currently it is being treated using drugs and psychotherapy. And we know that animal-based therapy have positive effects to relieve depression, but it has limitations. For example, people who are already affected with depression, they are not able to take care of animals who are able to give them good therapy effects. And animal robot therapy for depression has potential, but currently there are no studies to support this. We went to a rehabilitation center in Malacca, and we did an intervention with 6 patients who were diagnosed with depression after stroke. And currently, all these patients are inpatients at the center, which means that they are staying at the center for a minimum duration of 2 months. And one of the selection criteria to become our respondents or to be able to take part in this study, they must be able to converse in Malay or English and able to stroke the robot, and they must be able to hear clearly because the robot will be having sounds to be able to calm them during the therapy. Okay. And based on our findings, Alhamdulillah, we found out that the social robot Paro, which is an animal robot, can be used as an assisted therapy method, followed by psychotherapy and drugs. And animal robot can overcome the limitation of real animal as an assisted therapy. Psychologists can use this new therapy model with ready-to-use animal robot for patients with depression. And finally, we concluded that the Paro robot has an ability to calm the patient, improve their mood, and lessen their need for drugs as medication for depression. And finally, about the social robot Furhat in autism habilitation, I was able to browse through the website, and I'm truly looking forward to working with Furhat in order to help children with autism in Malaysia, because this awesome robot is able to train social skills as they are able to simulate situations with a human. And most importantly, the robot can be programmed to train the children with autism at a personalized pace, because we know that a child with autism is unique. So we can tailor-make the therapy according to the child's needs. And by having Robot Furhat on board, we may be able to reduce the dependency on therapists, because we know that Malaysia don't have enough therapists to help in the rehabilitation of people with mental disorders. And based on this MIT technology review, the advancement of socially assistive robotics has opened up a promising new way for children with autism and people with autism to get not only affordable, but personalized care. And finally, in 2010, Professor Ishiguro, who is the man who had created an android who looks exactly like himself, he has been saying that in the future, robots will be able to help in household chores, to care for the elderly, and assist with therapy. And he's been saying this since 2010, and we can see it happening now. And with that, I thank you. I would be happy to answer your questions. Thank you.
Thank you, Dr. Syamimi, with the very insightful contents related to rehabilitation robotics, also HRI. And I think it's a very good time for us to explore Furhat for autism children. As we all know, in robotics, in order for us to deliver the robotics to the society, we need 3 things. One is the good platform, the good contents, and the good applications. So Furhat probably one of the best platforms so far in terms of socially communicated robots. And we need researcher that able to come up with the good contents in machine learning or even in artificial intelligence, in linguistic, yeah, in order to make the robot able to communicate well with humans. And then we will work with the industry in order to tap with the applications. Perfect. So we have several one questions from our participants, but it's already answered by Dr. Azizi. Can Dr. Azizi maybe elaborate a bit more on the question here?
Okay, I think that the question is about the validation parts of the trust model. So currently we developed the trust model from, we built mathematical model to understand trust. So we have tested our model. It is one of my PhD students project where he tries to analyze how robot capable to measure trust time for the behavior change intervention. Because in this project, he uses one of the social robot to actually that empower individuals from their what we call dormant lifestyle to become a little bit active. So we use this kind of model. We tested for almost then 2 weeks to 3 weeks. Yes, we wanted to do more, but really we have limitation to access with the robot as well. You know that social robot pretty quite we call it limited in terms of quantities to be used back in our lab. So that's why we shortened our testing period 2 weeks. So based on that, we have questionnaires as well to validate the correctness of our model. The reason why we didn't use questionnaire all the time because it's counterproductive. So having the models that we measure from their individuals database of interactions, their progress, and also their conversation with the robot, the model can actually technically predict the level of trust of interaction or collaboration with human and robot. So from that postulate, we know already that if there is a positive correlation between that, so technically we assume that the robot-based intervention actually works. Because it's quite difficult to measure as per se, but we make that kind of an assumption. So far the results seems positive in general.
Thank you, Dr. Awesome. So I have a question to Dr. Syamimi. You know, based on your research, you have been using a humanoid type with a very fixed face now robots, and then move to animal type, and then we have now a humanoid with the own face expression that very dynamic. So how actually the acceptance and perception of for example, children with autism that you can expect from this?
Okay, thank you, Doctor. I think it's very interesting to observe what will be the reaction from children with autism when they saw Furhat for the first time. And I think we shall need to do a pilot study in order to have observations on this, because first they need to acknowledge that it is actually a robot. Because it has no arms or legs, and they would be very interested as it can show different type of emotions, but at a controlled pace. For example, when smiling, we can control it for a duration, a specific duration, and we can teach the children that this is actually a smile. And yeah, I think Furhat would be brilliant for children with autism.
Thank you, Doctor. We have one question here. Hello, Dr. Syamimi. Is there any consequences so far from your experience and research when using robotics with children with a child that have autism disease? That's one question, I think. And then second one is such as how will they behave towards their parents and maybe real people after using the robot, and how the robot can impact the child life in future. 3 questions.
All right, thank you.
The
first one is any consequences so far. Okay. So far, after we introduce the robots to the children, whenever we come back to the center without the robot, the children will be expecting us to bring the robot again. So they associate us, the team, with the robot. And they even ask, where can they buy the robot? Because they want to have it at home. And they were also very excited because the robot can play music and also dance. And like I've mentioned in my presentation, we were very happy to see that some autism traits of the children, such as communication disorder and social deficit, were actually reduced during the interaction with the robot compared when the children were interacting with their teacher, because we compared what were their scores when they were interacting with the human whom they normally interact with, and with a new novel object, which is the robot, which can play music and have colorful eyes. So in general, in a nutshell, the children had shown reduced autism traits after during the interaction with the robot. Next would be any difference on how the robot was perceived by humans in different sectors. How will they behave toward their parents or maybe real people after using robot to communicate with the child? Now, sadly, we did not have the opportunity to have a very lengthy study with involving the children with autism. Only that, as I mentioned, they would like to see more of the robot, and not only in the experimental setting. So they would like to touch the robot, pet the robot, and shake hands with the robot. And how can the robot make an impact to the child life in the future? Most importantly, the humanoid will be able to help the children with autism with social skills and understanding emotions. And I think that is very important for these kids with autism to learn to make friends and control their emotions during interaction. That's all from me.
Thank you, Encik Wan Ahmad Azwan, for the question. And I will like to add one point based on this research that we done last time. We have seen that the autism behavior have been reduced about 20 to 25%. Even the number of subjects is not that significant, like more than 30, but based on the 12 children, I think we have managed to come up with the conclusion that the autism behavior will reduce. Okay. Next, thank you, Encik Wan Ahmad Azwan. And then Devasin actually adding one questions here to Dr. Azizi. Yeah. So did you find any difference on how the robot was perceived by human in different sectors when compared to fully bodied human robot? And will their interaction with the robot and the acceptance of the robot change?
Okay, for this particular question that I can answer from my experience from my PhD work, but we test our robot together with like one of Dr. Syamimi's work with Paro, and also we built our own robot. We call it Pamela. I don't want to give a fancy name, but they gave it like that. Pam came from Pamela Anderson, and also that one of them we built robot that only like the furball. Right, so we tested these three conditions as well. So it shows, it depends to what kind of task. Because my work before, we developed a computational framework for the analysis of unipolar depression, their recurrence and also remittance. So it shows that the result almost the same. I mean, almost identical in terms of their effectiveness. So it depends on the particular task. In this case, to provide intervention and support, social support, and also connecting people. Fully bodied humanoid robot will not give a fair advantage compared to other what we call other platform robots. But perhaps that when it comes to the stroke training therapy, then post-stroke training therapy, then it give some significant result because you need to show the movement. Okay, it would be different if you try to play on the videos compared to the real settings of humanoid. But from our work before, it shows not much different, right? Even some bottleneck as well we can see when we put the fully working humanoid robot in the wild. We need to be what we call precise with the place and structure because they are quite fragile, right? And also they are extremely dangerous to put it anywhere. But compared to the tabletop like robot like Furhat, they can simply put it anywhere without being afraid of having some difficulties later. So that's my experience handling this type of robots.
Thank you, Doctor. So from Mr. Zakri, dear robotic expert and fan, do share and spread your knowledge, thoughts and expertise in the form of multimedia content paperwork via our digital content platform. Thank you, Mr. Zakri. And with that, I would like to move to the next sessions We're going to have another Q&A session after the demo. So if you still have a question or you want to, to give your opinion or any idea, we can have it at the last session after the demo. Over to you, Murshid.
Thank you, Dr. Hanafiah. That was a great talk from the moderator and speakers. Now we will go forward to our next session, which will start with a live demo of Furhat robot from Furhat Robotics, Sweden. We have also posted the quiz link in the chat, so you can have a go with the quiz. So let's start the demo. Over to you, Nils.
Thank you, Murshid, and thank you, Dr. Hanafiah and Dr. Syamimi and Dr. Aziz. It was a great talk and a great conversation there. I really enjoyed it. It's I wrote down some things here on my phone, some really good notes there that you mentioned that I think was really interesting to hear. But I think maybe it's time we got to meet Furhat, because I think a lot of you, that's what you were hoping to see. So Furhat, can you wake up? I think it's time to start the little demo.
Hi there, Nils. Good to see you again. And hello there to you too. How are you today?
I'm pretty good, thank you.
Yeah, I feel pretty good myself this wonderful Wednesday. All right, enough with the chit chat. Let's start today's presentation. I am a Furhat robot and I consider myself the cutting edge of social robotics. I'm here in this world to make technology more conversational and more social. You could say, more human. Some people find human likeness in robots to be uncanny. But I can reassure you, most people find me rather delightful. Would you agree?
Yes, I agree. You're an absolute delight.
I have a very lifelike and expressive face. Combine these capabilities, and I can portray lifelike characters. Should I do some characters with different faces and voices?
Yeah, let's do that. Show us what you got.
All right, let's go.
Avoir une autre langue, c'est posséder une deuxième âme.
To have another language is to have a second soul.
Hello there, human. I am a speaking robot. Yep, I know. That was dope. That's because that's what I do. I do dope because I'm Jimmy.
I feel like I might have an identity crisis soon. Nils, tell me, am I back to my regular self?
Yes, you're back. Maybe I'm gonna take your hat off so they can see you better maybe.
But there is more to me than just my face. In a real conversation, having eye contact is very important. I can even see where the person's attention is and recognize if they are smiling. So, when you walk up to me, I can detect you, look you in the eye, say hello, and return your smile. Let's try that. Please look away and let's pretend we just met.
Okay.
Hi there,
While I'm
stranger.
looking at
Can I
you,
have your attention?
the robot is gonna wait for me to actually turn my head and look at the robot, and then it will continue the interaction.
Now that I have your attention, how about a smile?
Yes, you can have
You
a
look
smile.
happy.
I am happy. Want one more?
Great smile. Now
Thank you.
that I know you are happy, we can continue with the presentation.
Sure.
This was just a very, very simple example of a conversation. I come with a powerful, extendable and easy to use dialogue framework and SDK, so that anyone can create interactions far more advanced than this. I hope you enjoyed this little demo, and that you get to experience talking to a social robot like me for yourself. Anyway, Thank you so much for coming to see me.
Thank you, Furhat.
My pleasure. If you don't mind, I'm going to go back to sleep now.
No, you can go back to sleep. All right, so that was just a very little quick demo of the different capabilities of the robot. As the robot said here, meeting the robot in person, like with the physical presence and having the feeling that the robot is looking in your eye and talking directly to you is really the powerful experience, and that needs you to be present together with the robot to experience that. So I hope that as many people as possible have the chance to be able to experience this firsthand. Before I hand back to Murshid, maybe I could just quickly introduce myself. So my name is Nils Hagberg. I work as product owner at Furhat Robotics. So I'm trying to be the bridge between the technology and our customers or research and other areas of touch points that we as a company have. Super. I hope that was a nice little intro to what this guy, girl, I'm not sure, can do. And now I'll pass it back to Murshid, and I'll stick around for some questions if you have any.
Nils, if you don't mind, can you explain about how many languages that Furhat can speak?
Yes. So when speaking about different languages, there's two things to keep in mind. One is be able to speak a language, and the other one is being to understand the language. And the robot can understand over 100 languages. So the speech recognition works in over 100 languages, and we're using state-of-the-art third-party services for this speech recognition. When it comes to speaking, the speech synthesized voices that the robot have are a little bit fewer than those 100. There are more, I think there are 40 different languages. But in each of these languages, there can be different voices and different genders of the voices and so on. Yeah, but there's always the possibility to use pre-recorded speech. So you can have a voice actor or yourself record the speech, and the robot can perform it and do lip sync automatically, so you don't have to worry about those things. So you can always get it to speak whatever language that you want. It would just be a little bit more of need for you to develop it. And I can also mention that we have some users that have integrated their own speech synthesizer with the robot. So they have a technical setup where they have their synthesizer set up on a server, and that will communicate with the robot, and the robot can then be fed audio files that it can play out with this automatic lip sync. Oh, can I just add one small thing to the question? There's also another important aspect of speaking languages is the natural language understanding part, being able to understand what people are saying and translate that to meaning. And the system that we have that is built on the work on Gabriel Skanse that you saw previously, and there are mostly of that work is language independent. So you would it works with different alphabets, and you will just create these different examples, and the intent classifier will then match what the speech recognizer said to this intent that you have defined. Sorry, so I just want to add that last part.
Thank you, Nils.
All right. Yes. Yes, Nils, go on.
I just said if you have any more questions, I'm happy to answer any that you might have.
Yes, Nils is a Furhat robot owner and expert in Furhat robot. So if anyone have any questions regarding Furhat robot, Nils can probably answer it. So that was a great demo, right? So let me just share the packages that we have for Furhat that is available right here in Malaysia. So we have three kind of package. So basic, standard, and premium. They comes with different perks. So different packages have different items, contents, which you can see from here. The basic package is comes with only 3 faces, and it can interact with 1 person at a time. Standard package is more standard in the sense that it can interact with multiple persons at a time and have access to more resources than the basic package. And premium package is actually we can customize the package depending on your need. So suppose if someone is in a retail store, they want the robot to be customized and catered specifically for the retail store, we can do that in premium package. So with that, I would like to stop talking about the packages, and next is our Q&A session. So please feel free to ask any question. Okay, Nils, I think there is a question for you in the chat box. Does the robot have its own emotions?
So the robot, out of the box, the robot as a platform does not necessarily have a personality or capabilities that showcase some kind of personality. So when you create an interaction, you should create also the personality for the robot. Choose a face, have a voice, create a script that match this personality, and make it express different emotions. So I would consider that to be part of what we call like the application layer. We call the applications these skills so you build in this kind of behavior and you build in this modality in that layer, and we provide you with all the tools necessary to easily create facial expressions and implement these different characters and good dialogues with the robot.
All right, thank you, Nils. There is another one. In view of the incoming metaverse, do you see the integration of our avatars in the metaverse sphere?
So I think to answer this question, I'm going to start from a perspective where I first met the robot and what really intrigued me about this piece of technology. And when I saw the robot, I immediately understood that this is like a bridge between the physical world and the digital world. So by that time, we had digital avatars, we had voice assistants, but they were kind of, in the cloud. They're not actually present in the real world. They're not actually interacting with you in the same space. But they're really powerful. They have so much, they're so intelligent and be able to use and be able to talk to them. So I saw with Furhat the combination of the digital and the physical, the embodiment of these digital avatars or these digital agents. So from that perspective, I think Furhat has some role to playing in this merging of the physical and digital world. The metaverse is perhaps a step towards going more into the digital sphere. So Furhat, if you would try to sort of use Furhat in that sense, perhaps Furhat could also be a tool how to make this metaverse become more physical, similar to how other technologies are bringing digital technologies into the physical world, like virtual reality and augmented reality and so on. But it's still so early days with the metaverse. I would like to see where that goes before making any real predictions about the future. But it's definitely interesting to see these kind of things happening. It's really, the future is really moving forward right now, and it's both exciting to see, but also really important that, like Dr. Aziz mentioned there, that we really bring in everyone into this work and this conversation. It shouldn't be just technologists working on these problems and developing these solutions. We need, psychologists and philosophers and these ethical discussions. We had this great question about trust. Like, there's so many important aspects that really need to come together. So it's nice to see that. I think this conversation is really picking up with this metaverse initiative.
Thank you, Nils. There is another question for you, I guess. It's, do robot can save the conversation history or emotion, so the robot can understand the person character and know how to treat different person based on their characters?
Yes. So again, I would say the main way to implement this, or the way we envision it, is that is something that you would create in that application layer. The robot itself, the platform, have some functions to support this. So there is a camera, and the camera can detect your face. It can also re-detect your face. So if you would leave the field of view and you would come back, you can detect that this same user as before. So we have implemented this as a tool in the platform. Technically, it's also capable to actually create a face print of your face, store it and in some database somewhere, and the next time, maybe 2 or 3 days later, when you show up to the robot, it can try to match faces that it has in its database with this new face to be able to remember you. These are areas where you need to have a clear and thought out design for how you do this in a good ethical way to keeping track of this biometric data that your face is. So we are a little bit careful on including this in as a built-in feature with the robot, but we encourage people to explore this when they have the robot and try it out. Other aspects of the conversation, like the kind of topics that you've talked about, the things that you mentioned in the conversation, this would be something that you will store in the conversation, and then you can, after conversation finish, store them in some database for later retrieval then. So again, this is really up to the developer of your application to build in this kind of memory, if you want to call it that, into the robot. And the robot can do some basic capabilities like emotion detection, so you can notice if a person has been smiling and have they been enjoying this interaction. You can detect their attention. Maybe you can have some estimation on how engaged they were in the interaction, have some metric for that, and storing that for another interaction or for this particular interaction.
All right.
So there's a lot of flexibility and opportunity for the developers to work with these things and create solutions and try out and explore and use their own systems, but then also use the built-in functionalities of the robot.
Thank you, Nils. So there is another question from Devasena. She is asking, can we customize the NLU dataset for the robot if we want to include our own intent action stories? Is it possible to manually code the YML files into the robot?
Yes, so it's possible on different levels. The robot if I start with if I start with one end, and that is the robot comes with, we call it a remote API, and you can use that to control the robot directly. And then you bypass a lot of that dialogue system and dialogue framework that robot comes with, but you have direct access. Robot, look over here, robot, say this, tell me how many people are in front of you, start speech recognition and give me the result. Then you have all the freedom in the world to do all of the different sort of processing that you want, having your own dialogue system entirely or anything. So that's one option, but then requires a lot on your part to create coherent and good interaction. If you stick with this Kotlin skill API that we have created, this skill framework that we have created, there are also some options how you can customize that NLU. There are some settings you can set on it, but then also you can just fetch these examples that the NLU is using to map to these different intents from some external systems. So you can have these examples and defining your intent.
Sorry, Nils, we cannot hear you.
Can you hear me now?
Yes.
Yes, I had a little microphone thing here. So I just switched microphones. So now I can hear you and you can hear me. We have some documentation on the webpage about how to do this. So if you're interested to actually try it out, your hands-on, you can try it with the virtual Furhat, and we can show you how you can define these intents in a more programmatic way, and having definitions somewhere externally, and having the robot just fetch them.
All right. Thank you so much, Nils. So we have came to an end of the session. Thank you very much for everyone to joining the session. And we hope that you can fill up the feedback form as well, put in the chat. Special thanks to the moderator and the speakers of the forum. And thanks a lot to Nils for giving the sweet demo. So I think we are about to wrap up. If Dr. Hanafiah wants to say something, please go ahead.
Yes, thank you again, everyone, for being with us for the past 1 hour, and thank you, Nils, for the awesome demo, Dr. Syamimi, Dr. Azizi, for the very insightful talk today. And I would like to encourage everyone to explore more about social robotics. 1 hour is definitely not enough. There's a lot of things that are happening right now in social robotics, especially when we are talking about Industrial Revolution 4.0. We're talking about digitalization and so on. So there's a lot of technology need to be explored. And I noticed here there's many students that are actually joining our session today. And for those who are actually interested to pursue a study in master or PhD in social robotics, you are most welcome. You can communicate with Dr. Azizi, Dr. Syamimi. I think he will be in USM soon. I'm not sure. And maybe also you can talk with me. We can, probably become a supervisor or point you to the right supervisor. And for that, I would like to thank you again for everyone. And please, you can always send any inquiries to us. I think my staff already shared the email address there. And there's a quiz, right? And I think the winner will be announced later.
Yes. So the winners will be announced by email. So okay. The winners will get a training with Furhat virtual robot to explore more.
And for those who want to see Furhat physically, there's one unit in our office. And very soon, our PSN, Pusat Sains Negara, also will have Furhat. So you can go to Pusat Sains Negara, the National Science Center. I think early next year they will start exhibiting Furhat, and you can eventually, have the real conversation with Furhat. Okay, so thank you again.
Thank you so much, everyone.
Thank you so much, everyone. In case you want to continue this connection, you can always reach to us. Right? Thank you so much for joining the session. Thank you.
Thank you, everyone. Dr. Hanafiah, the one in science can speak in Malay, I guess?
We're working on that.
Okay.
It's still in maintaining English for the beginning.
Okay. All right. That would be interesting.
Yes. Bring your Mikhail there.
Okay. Thank you, everyone, for inviting me. I hope it was an insightful sharing. Thank you. Thank you, Dr. Azizi.
Yeah, thank you. Stay safe, be safe. All right. Thanks, Dr. Hanafiah, Murshid, for organizing this session. Thanks a lot.
Yeah, all the best.
Thank you, Doctor.